Hello and welcome to Kelsey Ed, a place to make learning technology easy. In today's video, we'll be looking at how barcodes work or their principles of operation. Please like, subscribe, and of course select the notifications so you can be the first person to know when new content arrives. We have three main types of barcodes that we want to look at. First of all, you'll be very familiar with this and should have seen it on pretty much every product you've ever bought, and that's the UPC or the Universal Product Code. We also have the code 128, which you may have seen on tracking or shipping. Maybe if you got a delivery from UPS or FedEx, something like that. They may have used one of these tracking barcodes before they made you sign for the package. And lastly, I'm pretty sure you're going to know this one, and that's the QR code, and you might have seen these or even used them yourself. And what we want to talk about today specifically is the principles of operation, and that's a really important term that you need to know, and that describes how the device actually works, what processes occur to make that work technically, and that is different from how it's used, why it's used, places it might be used, its advantages, its disadvantages. All of those are separate from principles of operation. And in the next video, we can take a look at that together. But today we want to look at principles of operation. And in examination, you need to be able to understand this term and understand that it is asking for how the device actually works. The first type of barcode is the UPC, the Universal Product Code, and it's universally found on pretty much every product in the world, and it stores a unique product identifier, and that goes into a stock database, so that's why we use it for automated stock control in the real life scenario. And there's other aspects to automated stock control as well that we'll look at in the next video. It can store 12 digits. It has 6 on one side and 6 on the other. So only digits are stored in this format. This is the smallest of the barcodes. It stores the smallest amount of data and it is purely digits. The next one is your code 128. And as I mentioned, it's used in shipping and tracking. It's called 128 because it can represent all 128 ASCII characters. It doesn't mean it stores all 128, but it has the ability to use them. So it means that it's not only numeric, it's not just numbers, it can store alphanumeric data. If you're not familiar with the term alphanumeric, well, the alpha is like alphabets, meaning letters, and then numeric is number data. So an alphanumeric data type can store both letters and numbers. Now, this is a bit bigger than your normal UPC barcode, and it can store up to 48 characters, although they won't always be that exact size. It can vary depending on the company and what it's used for. The last one is our QR code, or quick response codes. And you want to be able to remember the word quick response for examination. That's a common terminology question. And this is used to provide really fast information, so we can get a lot of data very, very quickly. And that's why advertisers love it, because it doesn't take up very much space, and advertising space costs money. So you can get a lot of data across in a very small advertising space, and you'll find them all over the place on your trains. You might have seen them on train doors, on menus, leaflets, all over, even in applications that we use for perhaps finding friends online. If you want to add me online or add me on Facebook or something like that, you can use the QR code. Now, it's made up of a matrix of dark squares on a light background, and those can be all sorts of colors. And this one, for example, is orange. It can be standard black and white. It can be a different color. It can even have an image on top of it. Now, we usually scan this with our mobile phone or an iPad. It can store the most out of all of these barcodes over 7,000 digits can be stored. So that again makes it a really small and cheap medium for businesses to use. It can store so many different types of data, URLs or a web address, V cards, which is like a contact card, whole MP3 songs, Bitcoin requests if you need to ask for some money. You could put a Wi-Fi access code on there if you had like a cafe and you wanted to quickly access the Wi-Fi code. It could be whole images, a whole PDF document, or links to an application in the App Store, and absolutely tons more. And just go online and find a QR code creator and look at the list of all the different types that you can have. It's an insane amount of different things that you can do with a QR code today. Now let's look in depth at the principle of operation for the UPC barcode. We won't do 128, but we will do the UPC and QR. Now the UPC is a sequence of black and white parallel lines, same as the 128 actually. So these are parallel vertical lines in sequence, and they represent the numbers 0 to 9 in each position. So in this position, I could have any digit from 0 to 9 could be stored in this position. Any digit from 0 to 9 could be stored in this position. Any digit, you get the idea. Now the barcode is separated into two parts, left and right. And those left and right sides can both store all of the characters from 0 to 9, but depending on which side they're on, the bit pattern will be different, and that's why they are separated from left to right. And the start, end, and middle are separated using what is called guard bars, as shown in this diagram. So how exactly do we know from that line that we're reading the number 0 or the number 7? Basically, we have bit patterns that are stored, and those vary depending if it is the left or the right hand side of the guard bar. So let's look at an example here of the number 4. The 4 appears on the right hand side of the barcode. So when we look at the bit pattern table, and these are set bit patterns for every single barcode, we want to look at the one in the right hand side. And on the right hand side, it should be a dark line followed by a light line, 3 dark lines, then 2 light lines. That is the same pattern that is seen here. So there's this one dark, light, dark, 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 light, light. That makes a bit pattern that can be represented in binary and understood by the computer. So a dark is a true state of 1, and a light is a false state of 0. So the bit pattern changes from dark, light, dark, 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 light, light to be read by the computer as 1, 0, 1, 1, 1, 0, 0. When you look at that down here, you can see one thin line and one thick line. And that's exactly what we see here. One thin line and one thick line. Now, the next aspect of these barcodes is to do with error checking. And we have different codes for the left and the right hand side, but they always have a consistent format. There will always be 2 light sections and 2 dark sections. So look at this example. These combined bits that are true make one dark section. And here is our second dark section. Then here we have 2 light sections. So these 2 bits make the first light section, and this one bit makes the second light section. That's the same on both sides. So 2 light bits here making one section, and 2 light bits here making another section. And then 2 dark bits here making a dark section, 1 dark bit for the next dark section. You may also notice that all of the starting bits on the left-hand side are a light colour, and all of the starting bits on the right-hand side are a dark colour. By starting with these colours on each side, and by making sure there's a clear separation between each of these, it stops errors in reading and bars merging together and being confused as a thicker bar when it should be two thinner bars. Furthermore, if we look down to here, there are actually a different number of bits on each side in either a true or false state. So over here on the left side, we should have an odd number of dark lines. So 1, 2, 3. So there are 3 dark bits on this one. On the right-hand side, we should have an even number of dark lines. So an even number of dark bits or true bits. So 1, 2, 3, 4. This might remind you of parity bits in error checking, which you do in Chapter 2 in the IGCSE. And that's because it's the same concept that basically we can know, well, the computer can know if the barcode is being read upside down or not, depending on the number of true bits that are found on the left or the right. And it is then able to process that data appropriately. So here's an example exam question for barcodes and its binary interpretation. So it says, in the following barcode, each binary is made up of 7 bars. So there's 7 bars here, 7 bars here. Each bar is black or grey, so we have a dark and a light, and the black bar is interpreted as a 1, and the grey bar is interpreted as a 0. So it says, write the binary numbers that would produce this barcode. So this question should cause you no problems whatsoever. All you're going to do is use these 7 squares that are available to be your 7 bits. Just make sure you're looking at binary number A, binary number A. So what we learned was that a dark line is a true state and a light line is a false state. Well, a true binary bit is a 1. So the first answer here is 1. So it's going 1, 1, 1. That's all our dark ones. Then a 0 for light. Next one, a 0 again for light. The next one is dark, so a 1. And lastly, a light 1, so a 0. And that is the bit pattern for binary A. You can pause the video if you want and do the next one yourself quickly. And then we'll put in this, so it's going dark, light, light, dark, 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 light. No problem, easy marks. So how is that data processed and read? Well, first of all, you're going to have your barcodes, and that will need to be read by a barcode scanner. The barcode scanner will shine a red light or a red laser onto the barcode, and this will then be reflected back to the reader. The light is shined on the barcode, it's reflected back, and then the amount of light that is reflected back is then read by a sensor. It's called a photoelectric cell sensor, similar to what you find in solar panels. And based on whether it is a dark or light line, the amount of reflected light will change. So a dark light will reflect very little light because black absorbs light, whereas a light line will reflect a lot of light, and those will be read as zeros. So a threshold value is set, and based on the amount of light that is read back, the computer is then able to decipher, is that a 0 or a 1, and create a bit pattern. That's the process. If you learn those 5 steps, you should be able to answer any exam question on the principles of operation. So next is the QR code. The principles of operation for that are quite similar to how a UPC barcode is read. but there are some differences based on the device that is used. To read a QR code, you need some sort of imaging device, which could be a QR code reader, but most likely is going to be your phone or an iPad. And that will shine light onto the QR code, which will be reflected back to the camera, similar to the UPC barcode. But this data is going to need to be interpreted through an application you can usually find within the App Store for free. But some of them have that already built into the phone now. So if you've got a recent Apple, you definitely have that built into your phone. Once it's been read by the app, it will also interpret the dark and light squares in a similar way to a barcode. The dark squares are going to reflect less light because the dark is absorbing the light, and the light areas will reflect more light, and based on that, it will read the data. It will also look at these squares in the corner, okay? And those squares that are found on the outside are called modules, and they are used for understanding and knowing the correct orientation for the decoding process. So they store data that needs to be read before it can be decoded. Then all that data from the dark squares is read, interpreted, and you are then directly given access to the data that is stored. That's the principles of operation, so how it works for barcodes on the three main types, and everything you need to know for examination on principles of operation. Stay tuned to the next video, where we will be looking at the real-life scenarios where barcodes are used, as well as examination questions to get you exam ready. I'll place a link to that video in the description once it comes out, and also you can click on screen now. If you enjoyed this video, please like and subscribe and turn on notifications so you can be the first to know when new content arrives.